Okay, so welcome back to the same lesson, pressure in liquids at rest, or pressure in a liquid at rest. This is the second and final part of the lesson. It won't be as long as the first part. So, now we're looking at the third part of the lesson, that is the third objective in the lesson. So, let's think about this idea of how we interact with fluid pressure, or liquid pressure specifically, in everyday life. You may not even be aware of it, but let's have a look at it. So, first things first, water tanks. Now, water tanks have to supply water to all taps in a building. Now, the further the tap itself is from the water tanks themselves, the greater the distance in meters, or height in this case, vertically speaking, the greater the distance the water must travel to get to those taps. Now that's interesting, because how does that affect pressure? What if you wanted to take a water tap on the ground floor of a tall building, so it's the furthest it can be from the water tanks themselves, and compare how water comes out of that ground floor tap to how water comes out of a water tap that is on the top floor, for example. How would that affect pressure? Pressure increases because the water has to travel a greater distance. A greater amount of force is exerted to ensure that the water travels that greater distance. So the water will come out at a higher pressure on the ground floor than it would do from a water tap that is on the top floor of the building, for example. Remember, pressure depends on height. It depends on height, i.e. distance in meters, obviously. But let's think about this in another scenario, swimming, for example. What would be easier? Would it be easier to swim across fresh swimming pool water or seawater? And why do you think that? Why don't you press pause and actually give those two questions some thought, and then press play, and then we'll go through it together. Alright, so by this point, hopefully you've given yourself enough time to give those questions some thought. Well, think of it this way. Seawater molecules. Let's just say at this point that it's easier to swim across fresh swimming pool water than it is through seawater. Let's just say that it's more difficult to swim through seawater. Why is it more difficult? You look at the key terms on the board to help you, on the screen to help you. Why is it more difficult to swim across seawater? Well, hopefully what you're thinking is the seawater molecules are more dense. They are more dense than the water molecules found in public swimming pools, for example. So what will the swimmer therefore experience when they are swimming in seawater? What will they actually experience a greater amount of? Hopefully you were thinking it. Higher pressure. They're going to experience more pressure as they swim through across seawater, or swim in seawater. So pressure doesn't just depend, remember, on height. It also depends on the density of a liquid. Seawater is more dense as liquids go. It's far more dense than, well, it is slightly more dense than fresh swimming pool water, for example. Pressure also depends on the density of a liquid. Well, here's another one then. This is, I hope you know what it is, it's a water dam. It's a dam. Now, here's a question for you to think about. Why are dams thicker at the base of their infrastructure than at the top? Why are they thicker? Think about water pressure. Think about depth of water. Why are they thicker at the bottom of their design, and they are thinner at the top of their infrastructure and design? Why are they thicker at the base? The reason why they are thicker at the base is because at the base of the dam, it is further down, it's further down in the water, or in the reservoir, for example, or the large lake. it's therefore experiencing a greater size of, well, a greater amount of pressure from the water. It's experiencing more water pressure because it's got a greater amount of weight of water molecules that is exerting a force, which is their weight, a force onto the dam. It has to be thicker at the base to withstand the greater amount of force, the larger size of force being exerted onto the dam itself, because it is it's deeper in the water. There's a greater weight of water molecules above the base of the dam, and that is all applying a larger force on the dam itself. That's why dams are thicker at the base than at the top. They have to withstand the greater amount of water pressure at that depth. The reason I actually brought up this particular picture, this is a water dam this is the dam in Mosul, Iraq. Now, the reason I'm mentioning this has nothing to do, directly anyway, nothing to do with your GCSE physics course. But the reason I brought up this particular one is because when ISIS militants became very well known and very much started to propagate their ideologies, but specifically began taking over key structural sites in the central provinces of Iraq, one of the key infrastructures that they sieged, you could say, was this dam. This dam was temporarily under the control of ISIS militants until its liberation at some point after the year 2014. There is some evidence that suggests that there was attempted sabotage to destroy its base and therefore, consequentially, flood major Iraqi cities with populations exceeding 1 million people. Hence, it's important to note, as young learners, dams are valuable, as they are potentially dangerous if they are structurally compromised or if their security is compromised. This dam supplies a great volume of water to vast swaths of the central and eastern provinces of Iraq. It's very important to know that, and I just thought that you should know that because that is a very important, in my opinion, important piece of history. So, here are some questions for you then. 3 questions, 2 marks each. I want you to press pause and give them a go. Use the keywords, use all of them. You can use any of the words more than once if you want to, but you don't have to necessarily. Yeah, you can use any of the words more than once if you want to. You can use any word that I haven't mentioned here either. I mean, hopefully I've mentioned all the words that you need. Anyway, that's enough of me talking. Press pause, give the questions a go. When you're ready for the answers, press play. Alright, so let's go through the answers together. So question 1, explain why the wall of a dam needs to be thicker at the base than at the top. To withstand higher water pressure, mark 1. Caused by greater force exerted by the body of water, mark 2. And here are the answers to questions 2 and 3. Question 2, the water has to travel a greater distance. Higher pressure needed for water to reach the ground floor tap, or you could say a greater size of force needed for the water to reach the ground floor tap, hence higher pressure. Question 3, pressure at a given depth depends on the density of the liquid. Seawater has higher density than fresh water, so the diver experiences higher pressure. So make the corrections that you need to make, guys, and that's about it really. Thank you for watching part 2 of this video. When you're ready, move on to atmospheric pressure, the atmospheric pressure lesson video, and make sure that you like and subscribe. Share this video and all the other content that you've watched so far, guys, on this channel with your peers. It is valuable insofar as it applies to your learning. So thank you very much, and move on to the next lesson when you're ready.